Good evening. Welcome to the live interaction session for our course Biomechanics. Today we will discuss on the contents of week 11. So let's start. So in week 11, mostly in week 11, mostly the measurement of orientation in 3D space that was being discussed. And this we have already discussed, not fully discussed, but we have mentioned this in the uh, last session where we discussed about our uh, DH parameters. If you remember the DH parameters we have discussed in the last session. So in Danavid-Hardenberg parameter, there is a matrix called transformation matrix that we used to denote by Ti. So this transformation matrix was a combination of rotation matrix plus translation matrix and the scaling matrix. So we will be entirely discussing about how the orientation, uh, is the angle in which something is oriented. So orientation of vectors or the components in 3D space, how that we are uh, expressing it. So there is a concept of rotation matrices. So we can use uh, the frameworks, our Cartesian coordinate frames we can fix, and how these frames can be rotated to get the new position or the intended position. So that rotation we can convert into three rotations. Rotation about, if it is in Cartesian coordinate, rotation about x, y, and z. So the rotation matrices will be Rx, Ry, and Rz. So this will be the rotation matrices. So suppose any component or vector has to be rotated in more than one uh, axis or planes, then there will be something called composite rotation matrices. That is, this will be these rotation matrices will be operated together to get the new position. So that's called the composite rotation matrix. And also we have discussed about something called quaternions, which is more relevant in the spatial orientation as well as in robotics. So that's also has been covered in the week 11 of our course. So let's move and check questions. So first question is, which of the following are true for rotation matrices? So first question is on rotation matrices. The question is asking which among the following statements are the true regarding rotation matrices. Options are: option A, the columns are orthogonal vectors. Option B, the columns are unit vectors. Option C, it follows commutative property. Option D, inverse of rotation matrix is it transpose. Once again, which of the following are true for rotation matrices? Options are: option A, the columns are orthogonal vectors. Option B, columns are unit vectors. Option C, it follows commutative property. Option D, inverse of rotation matrix is its transpose. Try to answer the question before we discuss the solution. Try to answer the question by yourself. Try to find the correct statements from these given four statements. There can be more than one correct statement also. The correct answers are option A, option B, and option D. So there are three correct answers. Only C is the wrong. So all these statements, that is the column are orthogonal vectors, column are unit vectors, and inverse of a rotation matrix is its transpose. So these three are true for rotation matrices. Next question. The devices used to measure orientation in 3D space include which among the following? Options are option A, optical trackers, option B, gyroscopes, option C, electromagnetic tracking sensors, option D, inertial measurement units or IMUs. So, which among the following devices can be used for measuring the orientation in 3D space? Options are option A, optical trackers, option B, gyroscopes, option C, electromagnetic tracking sensors, option D, inertial measurement units. Inertial measurement units. Try to answer the question. Correct answers are correct answers are all of the above. Which among the following devices can be used for measuring the orientation in 3D space? Options are option A, optical trackers, option B, gyroscopes, option C, electromagnetic tracking sensors, option D, inertial measurement units. You can inbox your answers. Yes, but the correct answer is all of them. All of these can be used for measuring orientation in 3D space. So the answer is a, in such questions you have to in exam you have to try clicking multiple choices whether it is accepting multiple answers or not. That you have to check whether. And also there is something like in NPTEL there will be squares if the questions most of the time if the questions is accepting multiple answers then there will be squares for you to choose from. If it is only selecting single answers you will have a circles, so that's also there, but that may not be correct all the time. I would suggest to try to click more than one thing if to check whether it is accepting more than one answers. So, Correct answer is all of the above. All the four options can be used to measure the 3D orientation. Next question. What does a quaternion consist of? What does a quaternion consist of? Options are option A, two real parts and two imaginary parts. Option B, a single real part and three imaginary parts. Option C, four real parts. Option D, four imaginary parts. So what does a quaternion consist of? Options are option A, two real parts and two imaginary parts. Option B, a single real part and three imaginary parts. Option C, four real parts. Option D, four imaginary parts. Correct answer is option B. It is a single real part and three imaginary parts. Coordinate has one scalar, that is a real part, and three vectors, which is the imaginary components. Answer is option B. Next question. Gimbal lock occurs when? When does the gimbal lock occurs? Options are option A, two axes of rotation align. Option B, a rotation exceeds 180 degrees. Option C, the rotation matrix become singular. Option D, the trace of a rotation matrix equals 0. Next question is, when does the gimbal lock occurs? Options are option A, when two axes align. Option B, when a rotation exceeds 180 degrees. Option C, when the rotation matrix becomes singular. Option D, when the trace of a rotation matrix equals 0. No, the correct answer is option A, when two axes of rotation align. So when two axes of rotation aligns, it what necessarily happens is like it will lose 1 degree of freedom. So there will be a loss of 1 degree of freedom will be there. It mostly happens when two axes of rotation align with each other. So then there will be loss of 1 degree of freedom, and such a condition is known as gimbal lock or gimbal lock. Next question. Next is a true or false question. The columns of rotation matrix are orthogonal to each other. The columns of rotation matrices are orthogonal to each other. Options are option A, true. Option B, false. Correct answer is option A, true. The columns of rotation matrix are orthogonal to each other, and that's a property of rotation matrix. So orthogonality is a defining property of the rotation matrices. Next question. Rotation matrices are commutative. This is also a true or false question. Rotation matrices are commutative. Option A, true. Option B, false. Uh, Rotation matrices are commutative. The statement is false. Rotation matrices are not commutative. So basically, what is a commutative property? Commutative property is like simply saying if A plus B is equal to B plus A, or A into B is equal to B into A. So this such a property in mathematics, uh, vector space, is known as commutative property. So in if this if this A and B are matrices, suppose this are A and B are matrices, then A into B will not be equal to B into A. So you can take any matrix and try to multiply, because matrix multiplication happens into rows into columns. So first rows of A will be multiplied again columns of B. So if you try to do by switching the places, then you won't end up getting completely different answer. So that's why matrix multiplications are not commutative. Hence, rotation matrices are also non-commutative. So the statement is false. Next question. Quaternions extend complex numbers to represent 3D rotations. Quaternions extends complex numbers to represent 3D rotations. Options are option A, true, option B, false. Yes, correct answer option A, true. Quaternion extends complex numbers to represent 3D rotations. So coordinates generalize the complex numbers to 4D for 3D rotation representation. So it becomes quaternions can be written to something like A plus Bi plus Cj plus Dk. So these are vectors. I, J, K are vectors. So it is something used to represent rotation, but uh, The rotation matrices are one way, the coordinates are other way of representation of rotations, mostly used in computer graphics and all. Next question. The measurement of orientation in 3D space includes which among the following? Options are option A, kinetics, option B, linear kinematics, option C, angular kinematics, option D, fluid dynamics. So the measurement of orientation in 3D space includes which among the following? Options are option A, kinetics, option B, linear kinematics, option C, angular kinematics, option D, fluid dynamics. Try to answer the question. Yes, C, correct answer. Angular kinematics. Angular kinematics is the study or measurement of orientation in 3D space. Next question. Which of the following systems cannot be used for hand kinematics measurements? Which of the following systems cannot be used for hand kinematics measurements? Options are option A, flex sensor based data gloves, option B, optical trackers, option C, electromagnetic tracking sensors, option D, force sensors. Which of the following systems cannot be used for hand kinematics measurements? Options are option A, flex sensor based data gloves, option B, optical trackers, option C, electromagnetic tracking sensors, option D, force sensors. Yes, correct answer. Option D, force sensors. So the word kinematics itself gives it away. So once the word force is there, it is something dynamics. So in kinematics, uh, we don't deal with forces. So by simple analogy itself, we can reduce the answer. Force sensor is used to measure the forces, not kinematics or the motion. Next question. Match the following. So you have given two groups, one and two. First groups include Euler angles, quaternions, option C, of the third on rotation matrix. On the second box, there A uses orthogonal unit vectors, B involves a 4D hypersphere, C defined by three rotations about principal axis. You can answer like what is the options for 1, 2, and 3 in the order. Try to match the following: Euler angles, quaternions, rotation matrix with uses orthogonal unit vectors, involves a 4D hypersphere, defined by three rotations about principal axis. Yes, correct answer. Euler angles are defined by three rotations in the principal axis. Coordinates are 4D hypersphere, we just discussed in the previous question, and rotation matrices uses orthogonal unit vectors. So correct answer is 1C, 2B, and 3A. Euler angle uses sequential rotations. Coordinates uses a 4D unit sphere, and rotation matrices have are made on orthogonal unit vectors or orthonormal basis. Next question. This is also a previous exam question. Which MATLAB function is used to create a filled 3D surface based on the provided coordinates? So in the third week, uh, the course covers a little bit of visualization of vectors using MATLAB, and there some functions are being discussed. So the question is based on that one only. Which MATLAB function is used to create a filled 3D surface based on the provided coordinates? Options are option A, plot 3, option B, mesh grid, option C, fill 3, option D, surf. Correct answer is option D, surf. Surf is the function used to create 3D surface based on provided coordinates. Correct answer is surf. Surf is short for surface plot. Next question. For the given rotation matrix in X, Z, Y sequence, compute the Euler angles. It's a difficult one, but this has been asked before also. So these are the sequence. So here, if you can't see, so these are the three rows. So first top of the matrix is 0.9757, minus 0.0697 and 0.2074. Second row is 0.1291, 0.9487 minus 0.2884. Third row is 0.1766, 0.3082, 0.9347. correct answer is second one, B. That is A of 16.9 degree, pitch of minus 10.26 degree, and roll of 7.41 degrees. So here it is asked for XZY combination. So in what combination? It's like Rx, RZ, RY decomposition. So you have to switch back into the rotation matrices and multiply to get this answer. Next question. Quaternion representation for rotation theta about axis V, where V is given by Vx, Vy, and Vz. What is the quaternion representation for rotation theta about axis V, where V is given by row vector Vx, Vy, and Vz? Is it option A, Q is equal to cos theta by 2, Vx sin theta by 2, Vy sin theta by 2, and Vz sin theta by 2? Or is it Q is equal to sin theta by 2, Vx sin theta by 2, Vy sin theta by 2, and Vz sin theta by 2? Or is it Q is equal to cos theta by 2, Vx cos theta by 2, Vy cos theta by 2, and Vz cos theta by 2? Or is it Q is equal to cos square theta, Vx sin square theta, Vy sin square theta, and Vz sin square theta? How will you represent a quaternion for rotation with the theta about an axis? Okay. So the correct answer is option A, this one. Because the correct formulation is like uh, quaternion Q is equal to cos theta by 2 plus V bar, sorry, V cap sin theta by 2. So this thing, V cap is the unit vector representing the axis, or uh, unit vector representing the axis of rotation. So this when expanded, where V cap is Vx, Vy, Vz. So when expanded, this sine theta by 2 gets multiplied inside, and becomes like this. That is cos theta by 2, and all the other component Vx, Vy, and Vz has sine theta by 2. So that's the correct choice. So if you see in the second one, everything has the sign. So this is wrong. The first vector component, sorry, scalar component is cos theta by 2, and all the vector components are sin theta by 2. So here everything is cos. So that's also wrong. So here, everything is cos. That's also wrong. So here it is cos and not theta by 2. It's theta here. So when the rotation is theta, then the quaternion takes theta by 2, the half angle. So that's what I just showed you now is known as the standard axis angle formulation for quaternion. Next question. For a counterclockwise rotation of 20 degree about the y-axis, the correct rotation matrix is which among the following? For a counterclockwise rotation of 20 degree about the y-axis, 20 degree and y-axis, the correct rotation matrix is which among the following? Options are option A, B, C, and D. Try to answer the question. Oh, no, it's a wrong answer. So let's write the rotation matrices. So Rx, if the rotation is about x-axis, then the matrix will be 1, 0, 0, 0, 0, cos theta, sin theta, and sin theta minus cos theta. It is about y-axis, then it will be so here if you see in x-axis the first row and column is unity 100 and 100, so that will shift to the second column. When it is y, this unit value will shift to y section, that is it will shift to diagonally here, so it will be like 0 1 0 0 0. Then this is the same thing without changing the thing, it will be cos theta, sin theta, sin theta minus cos theta. So this is the RY matrix. Next RZ is equal to, this will shift one down. It's like the last column will be 0 0 1 0 0 and again cos theta, sin theta, sin theta minus cos theta. these are the three rotation matrices. So here the question is about y-axis. So here you have to find this thing, this combination. So from this, this is about x, this is about rx. So this is about ry, this is ry, and this is rx. So you can just eliminate option A and D, and from these two, how to find. So if you don't have a calculator and everything, then the things will be pretty difficult. But here also, you can see uh, there is uh, some what say uh, this is not a non-standard angle. It's a 20 degree. It's not a standard angle. If it is 30, 45, 60 or 90, we could have easily find out from the triangles, standard triangles. But if you see here, this here's a point 0.5 is a for 30 degree and 60 degree. This point 0.5 will only come for 30 degree and 60 degree. So from that thing, we can easily cancel this one also. So the correct answer is option B. And if you see here, the negative in these two things have been changed because it's a counterclockwise rotation. So that's why for counterclockwise rotations, the minus changes, it will becomes uh, minus sine theta, not minus cos theta. This the sign in the second row, the sign swaps. Which are the thing is like everything will be same, but the thing this negative sign changes. That's why these both have negative here, not here. Hope that helps. Next question. A quaternion 0.707 0.707 represents the rotation of dash degree about dash axis. So what does the quaternion Q is equal to 0.707 comma 0 comma 0 comma 0.707 represents? What is the rotation and the axis? Options are option A 45 degree about x axis, option B 90 degree about z axis, 90 degree about x axis, 45 degree about z axis. Try to answer the question. The quaternion Q is equal to 0.707 0.707 represents a rotation of dash degree about dash axis. So if you remember the previous formulation, Q is equal to cos theta by 2 plus Vx sin theta by 2 plus Vy sin theta by 2 plus Vz sin theta by 2 You can answer the question. So here if you see, these two components are 0. That is x and y components are 0. So when will something becomes 0? This, you don't have to go about the angle values and all, but this itself gives away. So when does the other two components, that is here if you say the vector v is equal to something like 0, 0, 1, because why it is 1, uh, this value and this value is the same. So from that we can reduce vz is equal to 1 and the other two are zeros. So when does this happen? This happens uh, only when the axis is parallel to z axis. So it is parallel to z axis or z axis itself. So that is 1 here. So it is about z axis. And degree of rotation also you can see that cos theta by 2 and sin theta by 2, that is cos theta by 2 equals to sin theta by 2. So when does this happen? This happens only when theta by 2 is equal to 45 degrees. So that gives theta is equal to 90 degrees. So from this simple thing, we can, with your presence of mind itself, you can deduce that the question is, because we don't have to find the numerical values of the angles, but still with the formulation, how the quaternion is formulated, by that itself you can find out the solution. Since we have two zeros, we can simply say the x and y component are 0, only z component exists. So it is about z axis, and from this you can, when cos theta by 2 and sin theta by 2 are same, then from that itself you can find the degree also. So option B is our correct answer. 90 degree about z axis. Next question. Singularity is a major problem usually incurred while using which among the following? Options are option A, Euler angles, option B, quaternions, option C, rotation matrices, option D, none of the above. Singularity is a major problem usually incurred while using which among the following? Options are option A, Euler angles, option B, quaternions, option C, rotation matrices, option D, none of the above. Correct answer is option A, Euler angles. So Euler angles, uh, the singularity is the same as symbol log. Euler angles is the correct answer. Next question, which is preserved under rotation? Options are option A, vector length, option B, vector direction, option C, coordinates, option D, basis, which is preserved under rotation. Options are option A, vector length, option B, vector direction, option C, coordinates, option D, basis. Which among the following is preserved under rotation? Options are option A, vector length, option B, vector direction, option C, coordinates, option D, basis. Correct answer is option A, vector length, because uh, under rotation the vector direction always changes and coordinates also changes with respect to that. So option A, vector length, is preserved under rotation. Vector length changes only under scaling. Rotation preserves magnitude but changes the direction. So the correct answer is vector length, option A. Next question. Eigenvector of a rotation matrix corresponds to which among the following? Options are translation direction, option B, rotation axis, option C, velocity, option D, scaling. The eigenvector, you might have studied eigenvectors in your school time itself. So what does the eigenvector of a rotation matrix corresponds to? Option A, translation direction, option B, rotation axis, option C, velocity, option D, scaling. Correct answer is option B, rotation axis. Because uh, rotation doesn't have to do anything with translation, so we can just cancel it. Even without knowing what is eigenvector of rotation matrix, you can solve the question. That's what I am explaining. So option A says about translation. So translation uh, is actual movement, not orientation change. Translation has nothing to do with rotation, so that is wrong. Then velocity, nothing is talking about velocity in kinematics. Then unless we are taking the Jacobian and all, then scaling. Scaling doesn't have anything to do with rotation. So only option left is option B, rotation axis. Eigenvector with the eigenvalue 1 is the rotation axis. That's why we had that 1 0 0 for rotation about x-axis and middle 0 and 0, and this formulation for ry. and RZ has 0, 0, 1. This kind of formulation. So eigenvector shows the rotation axis. Next question. Quaternion avoids which among the following? Options are option A, drift, option B, gimbal lock, option C, noise, option D, scaling. What does the which among the following does the quaternion avoids? Options are option A, drift, option B, gimbal lock, option C, noise, option D, scaling. The correct answer is option B, gimbal lock, because the Euler angle formation, or rotation matrix formation uh, lead to the loss of 1 degree of freedom, creating the gimbal lock. To avoid that, the formulation of quaternion was proposed. The quaternions eliminates the singularities of Euler angles. By singularities, we mean the gimbal lock. Next question. Unit quaternion satisfies which among the following? Options are option A, norm is equal to 0. Option B, norm is equal to 1. Option C, norm greater than 1. Option D, norm less than 1. What does a unit quaternion satisfies? Is it option A, norm is equal to 0? Is it option B, norm is equal to 1? Option C, norm greater than 1? Option D, norm less than 1. Correct answer is option B. The norm is the uh, squared sum of all the terms. So unit quaternion is when uh, satisfies the norm is equal to 1. Correct answer is option B. Norm is equal to. Next question. The quaternion multiplication is what? Options are option A, commutative. Option B, non-commutative. Option C, linear. Option D, symmetric. You can easily answer the question by recollecting the previous discussions. The quaternion multiplication is what? Options are option A, commutative. Option B, non-commutative. Option C, linear. Option D, symmetric. Correct answer is option B, non-commutative. Quaternion multiplication is not commutative. Next question. In, in a quaternion, the scalar part represent which among the following? Options are axis, option B sin theta by 2, option C cos theta by 2, option D theta. So what does the scalar part of a quaternion represents? Option A axis, option B sin theta by 2, option C cos theta by 2, option D the theta. We have seen this before itself. Answer is option C, cos theta by 2. The scalar part, that is Q is equal to cos theta by 2 plus P bar sin theta by 2. So this is the vector part. This is the scalar part. Scalar part is cos theta by 2. The scalar part of a quaternion encodes the half angle, cosine of the half angle. So what half angle? The angle by which is being rotated. If theta is the angle being rotated, then it will be theta by 2. Next question. The vector part of a quaternion represents which among the following? Options are option A, axis cross cos theta by 2. Option B, axis cross sin theta by 2. Option D, axis cross theta, axis only. What does the vector part of a quaternion represents? Axis into cos theta by 2, axis into sin theta by 2, axis into theta, axis only. Correct answer is option B, axis into sin theta by 2. And V bar represents the axis or the unit vectors of the axis, that into sin theta by 2. Vector part of the quaternion is the axis scaled by sin theta by 2. Next question. Which representation uses 4 parameters? Which of the following representations uses 4 parameters? Is it Euler angles? Is it rotation matrix? Is it quaternion? Or is it axis angle? Which representation uses 4 parameters? Is it Euler angles? Is it rotation matrix? Is it quaternion? Or is it axis angle? Correct answer is option C, cotinine. So, as discussed before, cotinine has A plus BA plus CJ plus DK. So, 1, 2, 3, 4. All angles have only 3. Sorry. All angles have 3. Yeah, pitch, and load. And rotation matrix, there are 9 components in the matrix, or 6 values. Then axis angle is only one parameter. So the correct answer is option C, cotinine. So what is the minimum parameters for a 3D rotation? What is the minimum parameters for 3D rotation? Is it option A 2, option B 3, option C 3, option D 9? What is the minimum required independent parameters for a 3D rotation? Correct answer is option B 3, because it's a 3D rotation, so there will be 3 degrees of freedom. So you have to define the 3 degrees of freedom to uh, represent the minimum parameters. That is the if it in case of Euler angles, it will be in case of Euler angles, it will be phi, theta, and phi. Psi, theta, and phi will be there to show the pitch, yaw, and roll. So all other things, all other uh, uh, like axis angle or quaternion requires 4 parameters. So minimum is 3, and all other methods needs 4 parameters minimum. So the correct answer is 3. 3 independent parameters are minimum. 3 independent parameters are required for define 3D rotation. Next question. The rotation matrices belong to which among the following? Options are option A SO2 or SO3, option B linear space, option C scalar field, option D vector space. So what does the rotation matrices belongs to? Option A SO2 or SO3, option B linear space, option C scalar field, option D vector space. The correct answer is option A, SO2 or SO3. This SO means special orthogonal. So something called group theory is there. According to group theory, the rotation matrices are grouped into uh, special orthogonal group. Rotation matrices belong to special orthogonal groups, and that is denoted by SO, representation SO, and 3 is the uh, order. If it is 3 by 3, then it will be written as S special orthogonal group 3, and if it is 2 by 2 matrix, then it will be written as SO2. So that's a naming convention. So the rotation matrices belongs to SO2 or SO3, that is special orthogonal group 2 or special orthogonal group of order 3. Next question. Determinant of improper rotation matrix is what? What is the determinant of improper rotation matrix? Is it option A 1? Is it option B -1? Is it option C 0? Or is it option D 2? What is the determinant of improper rotation matrix? Is it option A 1? Is it option B -1? Is it option C 0? Or is it option D 2? which is numerically more stable for interpolation. Options are option A, Euler angles, option B, rotation matrices, option B, quaternions, option C, vectors. Correct answer is option C, quaternions. Quaternions gives more stable interpolations. Quaternions enable smooth interpolations known as slurp, because quaternions gives a spherical system. It that way it is shown, and this slurp is short for spherical interpolation, spherical linear interpolation, in short slurp. So this type of interpolations makes uh, gives smooth interpolations for quaternions. Next question: when does gimbal lock occurs? This question we have already discussed, so we know the answer. Option A, when two axes align. So gimbal lock occurs when two axes align with each other. Due to gimbal lock, 1 degree of freedom is lost due to axis alignment. Next question: the trace of an identity matrix in 3D is what? What is the trace of an identity matrix in 3D? Options are option A, 0, option B, 1, option C, 2, option D, 3. What is the trace of a identity matrix in 3D? The correct answer is option D, 3. So trace is sum of all diagonal elements. So trace of a matrix is sum of all diagonal elements. For an identity matrix I, the elements are 1, 0, 0, 0, 1, 0, 0, 0, 1. So sum of the diagonal elements, that is 1, 1, 1 becomes 3. The trace of identity matrix in 3D is 3. Next question: a valid rotation matrix must be what? What should be a valid rotation matrix? Options are option A, symmetric, option B, orthogonal, option C, skew, option D, singular. What should be a valid rotation matrix? Options are option A, symmetric, option B, orthogonal, option C, skew, option D, singular. Correct answer is option B. So we have already discussed that the rotation matrix should be orthogonal or orthonormal. So this orthogonality is the fundamental thing or fundamental property that ensures the valid rotation. So the correct answer is option B, orthogonality. Next question. Quaternion conjugate is used to what? What does a quaternion conjugate used to? Options are option A, scale, option B, invert rotation, option C, translate, option D, normalize. What does the quaternion conjugate used for? Is it option A, scale, option B, invert rotation, option C, translate, option D, normalizing. The correct answer is option B, inverse rotation. So we have seen that quaternion is Q is equal to A plus Bi plus Cj plus dk. So this is a quaternion, whereas a quaternion conjugate is written as Q star and is equal to it is obtained by reversing the sign of the vector component. Reversing the sign of vector component. Sign of vector component. So this is the vector components. So by reversing the signs, it will become A minus Bi minus Cj minus dk. So this gives the inverse of rotation. So quaternion conjugate is used to invert the rotation. Correct answer is option B. Next question. Rotation matrices suffer from which among the following? Options are option A, redundancy, option B, drift, option C, noise, option D, scaling. Rotation matrices suffer from which among the following? Option A, redundancy, option B, drift, option C, noise, option D, scaling. Correct answer is option A, redundancy. Rotation matrices suffer from redundancy because we will be using 9 elements of a matrix when the rotation matrix is 3 by 3, so which means 9 elements, and it only represents 3 degrees of freedom. So rotation matrices suffer from redundancy. Next question. Which representation is minimal and singularity free? Which representation is minimal and singularity free? Options are option A, Euler angles, option B, quaternions, option C, rotation matrices, option D, axis angle. So correct answer is option B, quaternions. Uh, use quaternions are minimal and singularity free. Among the uh, four choices, quaternions representation use the minimal and singularity free method. Answer is option B. Next question. The composite rotation R is equal to Rz into Ry into Rx implies which among the following? Options are option A, X applied first, option B, Z applied first, option C, Y applied first, option D, simultaneous. What does A, what does a composite rotation R given by Rx into Ry into Rx implies? Options are option A, X applied first, option B, Y applied first, option C, option B, Z applied first, option C, Y applied first, and option D, simultaneous. Correct answer is option A, X applied first. So when in composite rotation matrices, or when we do these kind of rotations, so it will be operated from right. So R will be multiplied on Ry. Then the resulting matrices will be multiplied on Rz. So this is the order of matrix multiplication for a composite rotation. The correct answer is X applied first and rightmost matrix acts first. Next question. The angle extracted from trace formula is, which among the following is the angle extracted from the trace formula? Options are option A, theta is equal to cos inverse of trace minus 1 by 2. Option B, theta is equal to sine inverse of trace. Option C, theta is equal to tan inverse of trace. Option D, theta is equal to trace by 2. which is the formula to extract, which is the formula to extract angle from trace formula? Is it option A, theta is equal to cos inverse trace minus 1 by 2, or is it option B, sine inverse of trace, or is it C, theta is equal to tan inverse of trace, or is it D is equal to trace by 2? Correct answer is option A, theta is equal to cos inverse of trace minus 1 by 2, where trace is the R11 plus R22 plus R33. That is the sum of what diagonal elements, it gives you the trace. The correct answer is option A, theta is equal to cos inverse trace minus 1 by 2. Next question. Which is not used for orientation measurements? From the following, which one is not used for orientation measurement? Option A, IMU. Option B, optical tracker. Option C, force plate. Option D, EM tracker. Which is not used for orientation measurement? Correct answer is option C. So before also in one question I have told the word force has nothing to do with the orientation measurement. So the correct answer is force plate. All three is used for orientation measurement, but force plate. Force plate measures the forces and not orientation. Next question. The quaternion normalization is required to which among the following? Options are option A, to remove drift. Option B, to maintain unit length. Option C, to avoid noise. Option D, improve speed. What is the requirement of quaternion normalization? Is it option A, remove drift? Option B, maintain unit length. Option C, avoid noise. Option D, improve speed. correct answer is option B, maintain unit length. Option B. But also, option E is also correct. To move in drift, or because the purpose of quaternion normalization is to remove drift. After quaternion normalization, you will get unit length vectors, but uh, it is done to remove drift or prevent drift. So you can say both A and B. Next question. Which representation is best for real-time robotics? Options are option A, Euler angles, option B, quaternions, option C, matrix rotations, option D, scalar. Which representation is best for real-time robotics? Is it option A, Euler angles, or is it quaternions, or is it rotation matrices, or is it scalars? Correct answer is option B, quaternions. Because we have seen Euler angles as singularities and rotation matrices has redundancy. So quaternions is best for real-time robotics. It removes redundancy, that's why it's efficient, and it avoids singularities. Next question. Rotation about same axis twice results in what? What does the rotations about same axis twice result in? Options are option A, sum of angles, option B, difference, option C, product, option D, zero. What will happen if you rotate twice about the same axis? Option A, sum of angles, option B, difference, option C, product, option D, zero. Correct answer is option A, sum of angles, because we are rotating twice. So first, if suppose first is the uh, first is theta 1, then second is theta 2, then it will be theta 1 plus theta 2. That will be the rotation about the same axis twice result in. Rotation about same axis at angles. Next question. Which sensor provides absolute orientation without drift over long durations? Options are option A, gyroscope, option B, accelerometer, option C, magnetometer, option D, IMU. Which sensor provides absolute orientation without drift over long durations? Option A, gyroscope, option B, accelerometer, option C, magnetometer, option D, IMU. Correct answer is option C, magnetometer. Magnetometers provide absolute heading using Earth's magnetic field. That's why magnetometers give readings without drift. Drifts are actually numerical inaccuracies. Next question. Which device is most prone to integration drift? Which device is most prone to integration drift? Is it optical tracker? Is it gyroscope? Is it magnetometer? Or is it EM tracker? Which device is most prone to integration drift? Is it optical tracker? Is it gyroscope? Is it magnetometer? Or is it option D, ultramagnetic tracker? Correct answer is option B, gyroscope. Because gyroscope uh, accumulate error over time. Gyroscope accumulates error or over time due to integration, and this will create something called integration or integration drift. Next question. Which system is most affected by metallic interference? Make the following. Which system is most affected by metallic interferences? Option A, optical trackers. Option B, electromagnetic tracking sensors. Option C, IMUs. Option D, cameras. Which system is most affected by metallic interferences? Correct answer is option B, electromagnetic tracking sensors, because electromagnetic can affected by metallic interference. So electromagnetic sensors is affected by metallic objects. Electromagnetic sensors or EM sensors. So that's all for today.